Hi, it's Terry Dennery of the MathWorks. I think this could be a short video, but I think it's a pretty critical one too. And so we're going to talk about collaboration because these systems, they are just too rich in too much specific detail of mechanics, electronics, controls, frequency response, software, testing, that no one person really, possesses all these skills anymore to really do the amazing things that are taking place. Yeah, I'm sure that's even an understatement. Um, anyways, I'm going to only really do a few things for the model, and I think it will, well, it's basically here, right? I just want to kind of simplify this. And it's kind of an important simplification because, again, it's going to represent, a portion of the team that will really be doing something quite important, right? And so I'm going to just take this right here, this selection, and we'll create a subsystem for that too. All right, seems pretty simple. I like that it's gonna make things less cluttered, but let's just kind of get into what this is really about. The, this signal is the command. I'm gonna just call it C. C for command. Okay, this is about the measurement. All right, and on this side, I'll just call it A sub M, and here it's gonna be A sub C. All right, and so with that assessment, I think I'll even call it assess. Okay, that we're able to do the comparison between what we want and what we're getting. Let's make it a little bit smaller just so the lines are parallel. Okay, and with that, that's the modification I want. What's so important about this is that we're beginning to see who the team is, right? So we go into the plant, it's clear. It's the mechanical engineering, design, and analysis team needs access and participation in this. And then the same thing for the electrical team, right? And I think that DC motors and mechanics are representative of that. Now we go into the controller. Well, there's actually a few things going on here. Again, PIDs and understanding, kind of the frequency response tools and the classic controls tools based on linear control theory. That's certainly important. But also they need their analysts who are going to understand mechanics, and it's true of electrical too, but you're going to need people who really understand mechanics and electronics being part of this. And then, I won't do it in this. I might do it in my next demo. But there's also this idea of right mouse click, and let's see, where is it? Right mouse click. Oh, this is a bummer. Okay, how do I do this? It's showing up off screen basically, but I'll just say it is a right mouse click to C, C++, HDL, and PLC coding that can take place. And so anyways, the an additional group is going to be the software group, right? So we're seeing all kinds of need for mechanical engineers, electrical engineers, software engineers, specific control design engineers, and frequency response experts. Um, and then in really kind of setting up this final block, I'm going to really assert the point that the test engineers are crucial too. And then you go into that space and you're going to realize it's very populated by kind of the same people. The mechanical engineers, electrical engineers, software engineers, people who really know hardware. Maybe we just say hardware engineers who know how to connect the right wires to the right, connection points. And as you kind of get into, measurement and comparison, or at least assessment of performance, you get into this really, really interesting space of what we call verification validation, and how you formally prove to yourself that you've created something that meets your I'll simply just call it your quality requirements. So, anyways, it's one of the best parts of MATLAB and Simulink and the approach of model-based design is it's accommodation of the entire team that needs to be involved in creating these amazing and amazingly rich systems. Thank you.